Okay, we are doing Chapter 6 review, Part 1, 6.1 to 6.3. So the first part of our review is functions and not functions. Functions and not functions. So we have an input, which is also known as x, and we have an output, which is known as y. -2, 0, 2, 4, put a box around it. -1, 3, 5. And we're going to use arrows to show our relations. So in a function, every input has only one output. So that means every input has only one arrow coming off of it. We're not worried about our outputs. We're only worried about the inputs. Every input has only one arrow coming off of it. So when I look at this, each input, or x, has only one arrow coming off of it. So each input, or x, has only one arrow coming off of it. So this is a function. Okay, let's talk about what not a function looks like. So we still have our input, which is x, -2, 0, 2, 4. We still have our output, which is y, -1, 3, and 5. We're still going to use our arrows. So the definition of a function says that every input has only one output. When I look at -2 has two arrows coming off of it. So it has two outputs. The output could be -1 or it could be 3. So my input -2 has two arrows. Input -2 has two arrows or two outputs. So because -2 has two different outputs, this is not a function. Okay, let's take a look at what functions look like as tables and ordered pairs. So we have this table, x, y, -2, -1, 0, 3, 2, -1, 4, 5. So this is a table, and this is what it would look like as ordered pairs. So the definition of a function is every input, or x, has only one output. So we're looking at our x's. I'm looking for duplicate x's. I don't see any duplicate x's. So there aren't any duplicate x's. Or you can think of it as every x appears only once. So because I don't have any duplicate x's, or every x appears only once, this is a function. Okay, let's talk about what not a function looks like as a table or ordered pairs. What not a function looks like. So here's my table. So here's what my table would look like, and this is what the ordered pairs would look like. So the definition of a function is that every input or x has only one output. Well, when I look at this table, I have -2 twice. So -2's output can be -1 or 3. So -2 has 2 different outputs. Same thing down here. -2, there's duplicate -2's, or there's more than one -2. So there are duplicate -2's, or another way of thinking about it, there is more than one -2 as an input. We're only looking at our inputs. So that means -2 has 2 different outputs. -2 has 2 different outputs. Therefore, this is not a function. Okay, now we know what a function and not a function looks like. I have 2 more examples for you, and they're going to look familiar. At least I hope they look familiar. So the first one, graph the function y equals x minus 1 using inputs -1, 0, 1, and 2. So when I look at these directions, we can kind of say, graph the equation y equals x minus 1 using x's -1, 0, 1, and 2. You guys have seen this. We need to create a table. And instead of us picking our x, they're telling us which x's we need to use. So we need to use -1, 0, 1, and 2. So they're giving us our x's, but I want you to notice there's a negative, a 0, and a positive. So now it's just substitution. Y equals, we're going to substitute -1 for x, -1. -1 and -1 is -2. So when x is -1, y is -2. Or when x is -1, the function of x is -2. And then we just substitute again. I'm going to substitute 0 for x. So when x is 0, y is -1. Now we're going to substitute again. I'm going to substitute +1 for x. 1 minus 1 is 0. So when x is 1, y is 0. And I'm going to substitute one more time. I'm going to substitute 2 for x. 2 minus 1 is 1. So when x is 2, y is 1. So now I need to graph it. -1, -2. 0, -1. 1, 0. And 2, 1. So this should look very familiar. We were graphing equations in chapter 4, and now in chapter 6, we're graphing functions. Different labels, but the same math. Okay, we have one more example. And this is going to look familiar as well. So use the graph or table to write a linear function that relates y to x. And the book gives us this graph. So the book gives us this graph. And the matching table for this graph would be -1, -3, 0, -1. So this graph and this table represent the same thing. These two represent the same thing. And what this is asking me to do, use the graph or table to write a linear function, also known as an equation that relates x to y. Well, a linear function or a linear equation we know is represented by y equals mx plus b. We know that b is the y-intercept. When x is 0, what is y? Well, let's take a look. This is where it crosses my y-axis. When x is 0, what is y? Or take a look at the table. When x is 0, what is y? -1. So I can put in -1. That's my y-intercept. We also know that m is the slope. And I know how to find slope on a graph. I'm going to pick 2 points, any 2 points. I'm going to use this point and this point. And I know slope is rise over run. So it looks like I'm rising 2, which is +2. And I'm running 1. What's 2 divided by 1? So this is how I find slope from a graph. But how do I find slope from a table? Well, I'm going to pick 2 points. 1, 2. So I have 1, 1, and 2, 3. I'm going to label these numbers, x1, y1, x2, y2. And I know the equation for slope is y2 minus y1 over x2 minus x1. So now I'm going to substitute y2 minus y1 over x2 minus x1. 3 minus 1 is 2. 2 minus 1 is what? What's 2 divided by 1? 2. So it looks like my slope is a solid 2. And then I just backfill. Y equals 2x minus 1. This is the linear function that relates y to x for this graph or this table. So we did this in chapter 4. We had to find the equation of the line, right? So it's different directions, different names, but it's the same math.